I'd like to start off by just kind of repeating how this class is going to be organized this year. So pretty much what we'll do is the topics in class that we'll start with is with a video lecture that I'll be doing ahead of time. And so it's going to go over some of those key concepts and the key terms that we're going to discuss later on. So everything kind of ties together. So then what we do in class is maybe we'll have assignments that are from readings or other class activities that's going to help you with the details of that topic. So one thing that's going to be important for us is to be able to take notes in this class. And I want to give you some guidelines as how you can take notes. And I'm thinking about, taking notes in a spiral notebook on paper, because this is something you can easily refer back to and you can use on quizzes. So that way you're not having to be online with your notes. So whenever you do take notes in this class, have it organized by unit and topic, and it's going to be pretty much in the order that we go in. So we're starting with unit 1 and then the different topics that go along with it. So what you're wondering what you should be taking notes on, you should focus on the learning objective. And I will have that posted at the beginning of each lesson that I do, each video lesson. It's my advice to you to do things to augment your notes, to add to your notes. Don't just copy every single thing you see on the screen. In fact, you're going to want to listen to what I say in the lesson, where I'm emphasizing particular parts that you maybe should definitely write down, or it's just maybe optional, okay? But you really should think about adding to them and maybe doing drawings or diagrams to help you understand those concepts. It's also recommended that you do maybe some kind of color coding. You can underline, highlight, have it organized so it's not just a bunch of, one big random paragraph but you actually have an easy way that you can access your notes. Now, vocabulary in this class, it's important to know the definition, but that's not enough. In fact, knowing the definition is just a small step. You're really going to need to understand the real world application. And so I'll talk more about vocabulary tomorrow to emphasize, what you should do with vocabulary. So this first video lesson is on Unit 1, Thinking Geographically. This is the basics, and our first topic is Introduction to Maps. So your learning objective is this. You're going to identify types of maps, the types of information presented in maps, and different kinds of spatial patterns and relationships portrayed in maps. So this is the very first topic of our AP Human Geography curriculum. So the learning objective is something you want to focus on as far as maybe how you can organize your notes and what you would take notes on. So I've underlined kind of those key parts. So let's get into the content here. So when we talk about different types of maps that we're going to be using in this class, we definitely can use reference maps, which show basic geographic features. That's just like your political and physical map, and I'll show you an example of that in a minute. But also, we really rely on what's called a thematic map. Okay, it's a special topic. It has a theme. So the map is not just showing you where a place is, but it's displaying information. That's what geography does. That's what maps do, is they are a visual of the world or of a particular place that displays information. And we're going to talk about some of these examples of thematic maps, the types of thematic maps. So when we go back to reference map, this is probably the kind of map you are most familiar with. This is, the map that shows countries, cities, or in the United States, it also breaks it down into states. Just a real basic thing about when you're trying to read these types of reference maps, oftentimes, if you can't tell the difference, is this the city that it's showing that's labeled, or is it a country? The countries tend to be in all caps. Like if you look over here, this map of Europe, whereas the cities are not in all caps. And that way you maybe don't get them mixed up. That's a basic reference map. It's a political map. There's also the basic physical map, another reference map, which shows things like rivers, mountains, elevation. Oftentimes a physical map will have maybe the outline of particular boundaries, but that's not the focus of the map. Really what we're going to be using more is the thematic maps. So this is an example of a thematic map, which is referred to as a choropleth map. Now, you don't have to write down the definition of a choropleth map. Really what we need to be able to do is be able to read these types of maps. So we're going to be reading and analyzing lots of maps throughout the year. And the very first thing I ever want you to look at, no matter what, is the title, okay? So this is percent of residents with bachelor's degree or higher. Now, you also want to think about those totals. So what other things do you want to look at? Well, that also includes date. If you look, it's updated September 8th, 2012. So, this is 8 years ago. Obviously, data can change, statistics can change, but now okay, well, 8 years ago, this was the percent with the bachelor's degree. So the thing about a choropleth map is it shows differences in shading or coloring. And in this case, you have the different shades of blue that shows percent by county. So the different shades of blue, usually the darker the shade, the higher the amount. So it could be a percent or it could be a number, and typically the lighter the shade, the less of whatever it is that it's showing. So that's a choropleth map. Notice it's all different shades of blue, okay? Other types of thematic maps are simply called dot maps. So it's just one dot equals a certain quantity of something. They're also called dot density maps. This is often used just to indicate, for example, this one's U.S. public libraries. So where you see a dot is where you have a public library, okay? And so you can obviously see certain patterns when you look at dot maps or any type of map. And that's what you need to be doing this year, is being able to recognize patterns. So you may notice, like, wow, look at the Northeast United States. It sure looks like they have a lot more libraries up there. But if you know anything about population distribution in the United States, you also know that it has a much denser population. You could even see the locations of cities based on this map. For example, if you look at Texas, you can see the I-35 cities, San Antonio, Austin, Dallas, Fort Worth. You can see Houston. There's also a type of map called a graduated symbol map. And with this type, you see that the size of the particular symbol will indicate a certain amount. So this is a U.S. oil consumption. And if you notice, the bigger the dot, or bigger the circle in this case, the more oil consumption. And then the key will indicate those quantities. So sometimes they use other symbols besides dots, but dots often are what is being used for a graduated symbol. Just think it's gradually changing in size. Another map that we don't use necessarily as often, but it would be still a thematic map, is referred to as an isoline map. ISO refers to the word same. So everything along the same line is the same, whatever it is that it's showing. So the continuous lines kind of join those points at the same value. So if you look, a most common isoline map you'll see would be this right here, a topographic map. And so each line represents a certain, elevation. You often can see it when you look at like weather maps. So everything within this certain line is a certain, 80s, 90s, etc. And in this case, this is nothing to do with physical features. This is showing you where Californian students prefer to live. And there you have everybody within the same line is a certain percent. So those are called iso lines, same line. This one's one type of map that most students look at and they get thrown off, and it's called a cartogram. And this is where you take some information and you put it in kind of this strange form. Oftentimes it's a world map, but it doesn't have to be, where you can see how things are all stretched out. So obviously it's not an accurate type of map, but it's how, an artist can depict what you see here is placed on this map. So this one is 2010 car and truck sales in million units, so million cars. And you can see, for example, China has the highest amount. Look how big China looks on the map. So this one is when where you really need to know your parts of the world to make it make sense to you and understand maybe the shapes of countries and places. Otherwise, it just may look like a big blurb to you. So this is the European Union. That's what that represents. And then the US is third. And then you may also notice that some parts are just crunched up where there's hardly anything. And so if it's crunched up and made to look smaller than it really is, that's probably because the numbers are significantly smaller. So it enlarges things, it makes other things smaller, it distorts the shapes. Other examples of cartograms, you can see Walmart, McDonald's, Starbucks, kind of like locations of those particular companies and how many they have in those states. And that's what you're seeing here. There's also something called a mental map, which is really something that is in all of our own minds. And so we all have maybe our mental map, where you can map out your drive to school or how you get to and from a place. And everybody's mental map will be a little bit different. And we'll be practicing with mental maps this year every now and then just to understand like the concept of spatial thinking. So spatial patterns is important for us to be able to understand maps. And what geographers do is they try to find patterns in what they're seeing. So a couple of spatial patterns you'll come across is you may notice that maybe it's dispersed. So thinking about like a dot map. If the population, it just seems like random dots kind of all over the place, they're not lumped together at all, that's dispersed. Whereas you could find patterns where, once again, if you're thinking population, where they're clustered. So you can see there's, clear patterns that you start to see. And that's what geographers are looking for, patterns. So this is a famous map. And this refers to an outbreak of the cholera in 1854 in England. And what happens is there's a doctor that maps the deaths caused by cholera in this particular neighborhood, but it also mapped the location of the water pumps. So what a geographer would do is try to make those connections and see if they can recognize any patterns to figure out, how can we solve this problem? So nowadays that would be called like an epidemiologist, somebody who would be studying the outbreak of disease. So what Dr. Snow does is try to find this correlation between the water pumps and the deaths of from cholera. So what did he find? He found a spatial pattern of clustering around a particular water pump. So if you notice the pattern, see how there's more deaths in this area. So what this meant was this pump right here was contaminated, and therefore that contributed to the deaths around this area. So when you know where, you can start to ask why. That's what geographers are doing. They're not just saying, where is it? And then that's the end of it. In this class, it's not about where things are. It's tying together the where and the why. So we got to get beyond just mapping something out and actually analyzing what that means. Other types of spatial patterns relate to location and distance. So throughout the year, we'll refer to absolute location. We'll talk about where exactly is a particular place. And so where can you get the exact amount? Well, think about nowadays we have GPS to get exact places. That's like your coordinates. GPS utilizes latitude, longitude coordinates. But an address is also an exact position. There's also something called absolute distance. So it's something that can be measurable between places. So for example, 5 miles is absolute distance, 5 miles from here to there, like two particular places. But what geographers also do is look at spatial patterns beyond what's just absolute to what's something called relative. So just think of the word relative and think relation. What's the relationship between places? So a relative location is going to be talking about a place in relation to other features. So I'll give you a couple examples here. So New Braunfels is northeast of San Antonio. That's a relative location. You're describing one place in relation to another place. So here we have San Antonio, northeast of us is New Braunfels. Walmart is across the street from Warren High School. So that's these places in relation to each other. There's no exact anything mentioned here. This also can tie into distance. So relative distance is measured in terms of the degree of interaction between places or in units of time traveled. So for example, sometimes we don't say, well, a certain place is 15 miles from here. We might use a term like, it's maybe like 10 minutes from here. So we use a term of time, which is really not a measurement of distance at all, but we can sometimes imagine the time and the distance. It's a relative way of speaking. It's also looking at the terms of the degree of interaction. Some places may actually kind of feel closer to each other because they are more connected, possibly through some form of, a highway system or road system, or maybe even like high-speed rail. They feel more connected because there's more access to be able to get to places. And that's relative distance. The last topic I'll cover with this lesson is about map projections. It'd be really interesting if you have a globe in your household, if you can go find that globe, and it makes things make a little bit more sense as I go through this. I'll also demonstrate this in class when we have a chance. But if you have a globe, pause this video, go find your globe, come back, unpause, and then you can kind of compare what you're looking at in front of you to what I'm talking about. So now I want you to picture a globe made of soft clay. Now imagine squashing it flat. Congratulations, you've just made a map. Sure, you've stretched out a few continents, but how else can you depict a round planet on a flat surface? Okay, so the whole point of what I'm talking about with map projections is the fact that the Earth is a sphere. Okay, and let me just point this out. All intelligent people know that Earth is a sphere, and we've known that for a long time. In fact, ancient Greeks were able to figure out the circumference of the Earth utilizing geometry and shadows and brains. Okay, so we know the Earth is a sphere. And the thing about making a sphere into a flat surface, into a 2D surface, you're going to cause some issues. So here we have, for example, you have the Earth. Now picture your globe if you have a globe. Now imagine having to make a flat map and flattening it out. Okay, it might look kind of weird, right? Like this orange here, if you were to try to flatten it out. So what this is called is a map projection. When you're taking something that is 3D, you're taking the spherical Earth and you're making it into a flat map. And the thing is whenever this happens, you're going to create some kind of distortion. Something is going to be thrown off as a result. So the shape of the place may get stretched. Distance between places becomes inaccurate. Sizes of places may be exaggerated or may look too small. And even the direction will be misrepresented. So it depends on what kind of projection you use, but no matter what, whenever you take a 3D sphere, a 3D surface, and you try to make it 2D on a map, it's going to create distortion. So here's an example of what I'm talking about here. So there's different types of map projections. You do not have to memorize these different types of map projections or, copy all of them down, but I do want you to recognize them and to understand that the different projections are going to have some kind of distortion where something is technically wrong from the real world. So this is a famous map that's used. It's called a Mercator projection. And you probably already realize the northern areas, like the North Pole area and the Antarctica, South Pole area, just looks really stretched out. And that's because they took all these lines of longitude, which technically all meet at the poles, and they stretched it out so that they are now perpendicular and crisscrossing with the lines of latitude. But what this does is it misleads us. If we've never actually looked at a globe, so if you have a globe, compare that to what you're seeing here and look at Greenland. Okay, Greenland is actually much smaller than South America, but compared to this on this map, it looks gigantic. And Africa is actually much larger than the United States, but this map would make you think otherwise. And is Antarctica really this big? No, it's not. Now, a lot of the times you'll see maps that are represented like this. So this is a conic projection. So this is the method in which they use to create a particular map. So sometimes their maps will typically have what kind of projection it is listed on there. So this is called a Robinson. Once again, you do not have to memorize that. But just be familiar. You notice that now the lines of longitude are a little bit curved, but it's still not perfect. It's still not perfect at the poles, right? But it gives a better depiction of the middle latitude areas, which is like US, Russia, China over here. So it's got more accurate in terms of the size and the distance, but there's still some distortion. Let's say you wanted to look at the North Pole or the South Pole. Well, these other two projections aren't very good with that. So if you want to look at the North Pole or South Pole, you would use a polar projection. So you definitely know that this is wrong because it only shows half of the Earth. You can only see one hemisphere at a time, the northern or the southern. But if you want to look at Antarctica in the best light, you definitely want to use a polar projection. And if you want to look at the Arctic, which is the north, and by the way, the North Pole, there is no land there. Sorry, no Santa Claus, just floating ice. So that is going to be important to use for looking at the far northern North Pole, South Pole, Antarctica, etc. You'll notice this type of map in your textbook, and I don't want you to be thrown off when you see this. Just ignore all those breaks in it. It's kind of that same idea of you're taking something round and trying to make it flat. Then it kind of stretches it out right here. But it gives you a better idea of the sizes of the continents, a little more accurate, but it's going to be interrupted and distorted kind of in these weird areas. Looking at Antarctica, you can see that. And you may look at this map and say, that's wrong. But is it? It's not wrong. It's a different view of the world. We're so used to looking at, north is up, south is down. That's not always the case. What if you were an alien coming from outer space and you land on planet Earth? Is there really like a north or south? That's just how we kind of orient ourselves in our heads and oftentimes on maps. But you can just look at this. If you analyze a little bit, it's just a different view of the world. I guess this is what Australians like to have, right? Now I'm going to include a video that's talking about map projections. It's a video clip from West Wing. It's an old TV show, just a few minutes long if you want to check it out. It kind of talks about the idea of Mercator projection and how we should change the map projections that are used in school. After you've viewed this video lesson and taken some notes, there is a 10-question quiz for you to do, and you have two chances to submit that, and then there's one question in the exit ticket discussion. So this completes our video lesson. Remember, you can always go back to this and you can add to your notes. I also have this posted with the video itself so you can refer back to the PowerPoint slideshow.